Hi, and welcome to Cyber.IT. My name's Anthony, and I'm your local subject matter expert here for Network Plus, and today we're going to be talking about the properties of IP addressing. So let's take a look at IP addresses. Now, we've talked about how IP addresses fit into our layer 3 of our OSI model and our network layer, but what are IP addresses? What do they do, and how do we compose them, and what do they look like? Well, IP addresses are our logically mapped addresses that map to a physical address. So when we say that they're logically assigned addresses, what we mean is that our IP address we can set for any computer. IP addresses aren't hard encoded to a computer, so we can map them to any particular physical address. We can map them to any MAC address that we want to. An IP address can point to one computer one day and the very next day point to a completely different computer. So our IP addresses are logical addresses. They can change. Our computers can have multiple IP addresses throughout the course of a day just because we move between different networks. So we want to understand that these IP addresses are not hard encoded. These IP addresses are provided to our computer by the network we're on, or are set statically by us. So we need to understand what these different IP addresses are and how we get them. So what's the format of an IP address? Well, an IP address is what's known as a 32-bit binary address. When you see an IP address on your computer, you'll see something such as 192.168.1.1. That's an IP address. Our computer doesn't know how to understand that just by reading the numbers 192.168.1.1. At its base level, computers only understand electrical signals. Computers can only understand on or off, a 1 or a 0 in binary language. Binary language is the language of computers, is the language of processors, and is the base level of how our computers talk. Binary lets our computers know if there is a signal that's on or if there's a signal that's off. And an on in binary is represented by a 1, and an off in binary is represented by a 0. So all of our numbers, all of our characters, all of our programs are all at their base level just a bunch of binary code that has been written out. So our IP address, our 192.168.1.1, is also binary code. It's a string of numbers that's made up by using this binary. So IP version 4 addresses are 32-bit binary addresses, which means that we have 32 ones or zeros in our address. We counted these out earlier, and we have 32 here. So the 32-bit addresses, we have 32 ones or zeros. These addresses are divided into 4 sections known as octets. And the reason they're called octets is because in each section they have 8 numbers. So how do we go from having an address that looks like this, 32 ones or zeros, to an address that looks like this, an actual numerical IP address? Well, these sections increment by powers of 2. So let's take a second there. What do we mean by that? Well, if we start at the very right-hand number of an octet, and remember, because we're breaking it up into 4, we're starting at the very right-hand side of an octet, a set of 8 separated by a period. This very first number in an octet represents a value of 1 or a value of 0. Think of it almost like an abacus with several different rods, but only one bead on each rod. If our number in our 0 or 1's place is a 0, is an off electrical signal, then it stands for a 0. If it's a 1, then it's an on. So when we move over to our next place, we increment by a power of 2, and our section now stands for a 2 or a 0. So if our next number in our octet sequence is on, if it's a 1, then that means that we add 2. If it's 0, then it's off. We don't add 2. And that continues on. We have 1's place, 2's place, 4, 8, 16, 32, 64, and 128. When we add up all of these together, if we have a string of binary in our octet, if we have an entire octet that is all on, if every single place is a 1, then our max number is 255. If all of our numbers in an octet are a 0, then our number is 0. That's our lowest number that we can have. Now, when you think of 0, when you think of numbers in math, you think of a null value. When you think of 0, you think of a nothing. In our IP addresses, though, an address with a 0 is a completely valid number, is a completely valid address. Now, not all zeros, but if, for example, our address here was 192.168.1.0, that's a valid address. So we need to make sure that or it can be a valid address depending on our subnets. So we need to make sure that we understand that if we're counting sequences of address, if we are counting how many numbers are possible in a certain octet, technically we don't have just 255 available. Because a string of zeros also counts as a digit, we have 256 values available. 0 to 255, because 0 counts as a value. So we have 256 values available, but the highest number that we can have is 255. Understanding that we have 256 total values available will come into play later when we're talking about some more complicated issues known as subnetting. But just remember that we have 256 total values available, but 255 is the highest number that we can put in. So we have our binary here. This is what our computer sees. This is our computer language. And we need to translate this binary into a number so that we can see. Well, let's start and let's just dissect this entire string of binary. Remember, our IPv4 addresses are 32-bit binary addresses divided into 4 octets, 4 sets of 8 numbers separated by a period. And we're incrementing we'll start with 1 and then increment by powers of 2. So let's start with our leftmost address here, our leftmost octet here. Now, if we take this octet and we'll fill it into our chart here, we already explained how our zeros place increments. So we start and we fill out our chart here. We have a 1, so we'll just fill in 1, a 0, 1, 1, 0, 0, 0, 0. So we have we'll start from our highest number and we'll go down. We have an on switch in our 128 place. So our number right now is 128. We have nothing in our 64 place. We have an on in our 32 place. So now add 32 because it's on to our 128. Now we add 16 because we have on our 16's place. And then the rest are zeros. So plus 0, plus 0, plus 0, plus 0, but we don't have to show those. So we have 128 plus 32 plus 16. And that will leave us with 128 plus 32, add the 2, carry the 1, we're going to have 160. And then we add our 16, and we're going to have 176. So our first number here is going to be 176. Now we have a first number. As you can see, this takes a long time, which is why we don't do this all by hand. We do have calculators available for this, but we need to understand at this point in our discussion, we need to understand how this is done. So our first place is 126. Now let's pick up the pace a little bit. Now our next place is going to be all ones. Now we already know that our highest value when we have all ones is 255, but let's show why it is. So we have a 1, an on, an on, an on, an on, an on, an on, and an on. We have no offs. We have no zeros in this octet. So we have 128 plus 64. 128 plus our 64 is going to give us 192. So 128 plus 64 is 192. And then we add that to our 32. And our 192 plus our 32 is going to give us 224. Our 224 plus our 16 is going to give us 240. Our 224 plus 16 equals 240. And now our 240 plus 8 is 248. 248 plus 4 is going to be 252. 252 plus 2 is going to be 254. And 254 plus 1 is going to be 255. So that's why our highest number is 255, because when all of our places in our octet are on, our number is 255. So let's take a look at our math for this number, or our math for this octet. So we have our place here, our 128 plus 64 is going to give us our 192. Now 192 plus 32 is going to give us our 224. And then finally 224 plus 16 is going to give us 240. So our 1, 1, 1, 1, 0, 0, 0, 0, the rest of these are zeros, so we don't add anything. We now end up with 240. So our IP address we have represented in red in a number that is easier for us to understand is going to be 176.255.0.240. And now we know how we figured that out. So now we know how to work forward with a number. We took our binary, our 32-bit address, and we worked it into a number, or we worked it into an IP address. So what do we do if we need to go the opposite way? We need to go from 192.168.1.1 into binary. This is useful when we're doing subnetting. This is useful when we're working with more advanced features of our IP addresses. So let's take a look and figure out how we do that. So let's keep our chart. This is a very useful chart, by the way. If you're taking an exam or you are in a situation where you need to do subnetting, or you need to do IP address functions that require you to translate it into binary, but you can't have an IP address calculator for whatever reason, then it's good to set up this chart first on a marker board or on a piece of paper, so that you'll have a template to work with. It's very good and very simple chart to set up. So we have our address, and now we're going to work backwards. Our IP address is 192.168.1.1. So what do? We take our 192 and we start from the left of our chart again and work to the right. And essentially, we start subtracting from our 192. And if our value is small enough to fit into our 192, we put an on in that switch, because our binary works from left to right. So that's how we need to start. So we have 192, and we start from the left. Is 128 smaller than 192? Yes. So we put on in our 128 place, but we also subtract that 128 from our 192. So we have 192 minus 128, and that's going to leave us with 64. Now, does 64 fit into 64? Yes, exactly. So 192 minus 128 equals 64, and 64 does fit into 64, so we put an on there. And then 64 minus 64 equals 0. So there's not going to be any more numbers here that fit into that. So nothing fits into 0. So the rest of these are going to be zeros. So that means our first octet for our 192.168.1.1, our first octet is going to be 11000000. That's going to be our first octet. 1, 2, 3, 4, 5, 6, 7, 8. Now our next one, our 168. So let's go ahead and clear our chart back out. So now let's move on to our next number, our 168. Now our 168, does our 168 fit into 128? Yes. So we put an on in our 128, and 168 minus 128 equals 40. Now, does 64 fit into 40? No, it does not. So we have an off in our 64 place. What about 32? Does 32 fit into 40? Yes, it does. So we put an on in our 32, and we subtract 32 from 40. And this is going to leave us with 8. Does 16 fit into 8? No. Does 8 fit into 8? Yes, exactly. So we put an on in our 8, subtract 8 from 8, leaving us with 0, and then the rest of our places are going to be zeros. So now our next octet is going to be 1, 0, 1, 0, 1, 0, 0, 0. Now our last two octets are fairly easy. We may even be able to do them without even referencing our chart a lot, but we'll reference our chart for one of them, just for demonstration purposes. Our next two octets are ones. So we have our 1 over here, but just so we form a habit, we're going to start from left to right, even though I think we all know where this is going. Does 128 fit into 1? No. Does 64 fit into 1? No. Does 32 fit into 1? No. Does 16 fit into 1? No. Does 8 fit into 1? No. Does 4 fit into 1? No. Does 2 fit into 1? No. Does 1 fit into 1? Thank you, finally, yes, it does. So 1 fits into 1, so our next octet and the one after that, because it's exactly the same, are all 0, 0, 0, 0, 0, 0, 0, 1. 1, 2, 3, 4, 5, 6, 7, 8. And then our last octet is going to be the same. 0, 0, 0, 0, 0, 0, 0, 1. 1, 2, 3, 4, 5, 6, 7, 8. So that's how we translate from our standard IP address to binary. And then we showed earlier how we translated from binary to a standard IP address, all with the use of our handy dandy little chart, and all with an understanding of how these binary switches work and how we increment. We start at 1 and we increment up our way by powers of 2.